Hi and welcome back, friends. Now in this video we are going to discuss that how to create a linked list. So let's start the video. So welcome to my class. So what's the today's agenda? So here are the two basic agenda. So first we're going to see that what is linked list, and next we'll see that how to create a single linked list of size n. Okay. So now let's move on to the first agenda, which is saying that what is linked list. Okay, so linked list is nothing but they are actually a type of linked list. That means singly linked list is nothing but they are actually a type of the linked list. Okay, so what are the characteristics of the linked list? So here are the basically two main characteristics of the linked list. So first is that they are unidirectional. That means it can be traversed in only one direction from head to the last node. So if you want to traverse your linked list from say from head to the last node, then you can do. Okay, but if you want to traverse your linked list from last node to head, then this is not possible because singly linked lists are unidirectional. That means you are allowed to only traverse in only one direction, and that direction has been already specified from head to the last node. Okay, so we'll see the reason for this, that why it is that we can traverse only from head to the last node, why not opposite. Okay, so in the next slide we'll see the reason for this. Now let's come on to the next characteristics. So as you can see that singly linked list consists of nodes, and each single node contains the data and a pointer. That means each single node is divided into two parts. So first part contains the data and the next part contains the pointer to the next node or address of the next node. That means it helps in maintaining the structure of the list. So these are the basic two characteristics of the single linked list that are necessary to know to characterize a linked list as a single linked list. Okay, now we'll see the diagrammatic representation of the linked list. So this is how linked list look like. So we have 5 elements or 5 nodes inside our singly linked list. Okay, so each node have 2 parts as we have expected earlier. Only first part stores the data and second part stores the next. So hence the data type of this node obviously will be struct node, because a struct node or the structure is the user made data type in which we can have more than one variable of different data types. Okay, so in my structure right now the name of the user made data type is a struct node, and inside that I have 2 variables. First is data, which is of int data type, and next one is pointer to store the address of the next node, which is of a struct node pointer. Okay, so you can also see one more pointer here which is pointing to the first node. So this is the pointer name head. Okay, it is also an essential part of this singly linked list family or linked list family in general. Okay, so head is very important. Okay, make sure that in your linked list you have a head pointer which is pointing to the first node, because only with the help of head you will be able to do any kind of operations, or either it can be deletion or either it can be moving through the list. Okay, so now head is pointing to the first node. Okay, and each node has 2 parts. First is data and next is storing the address of the next node. So similarly, if you see these links, so you will find that these links are in forward direction. That means from left to right. Okay, this specifies that you can traverse the linked list only this direction, from left to right. That means from head to the last node. So if you want to traverse from the from opposite direction, that means from last node to head, then it is not possible, because if you come to this point, then the address of the next node has not been stored in the opposite direction. The address has been stored such a way that the link is in forward direction. That means the link is in from left to right, not from right to left. Hence you cannot traverse the list from last node to head, but you can traverse the singly linked list from head to last node. So this is the basic explanation of the singly linked list. Now in the next slide we are going to discuss that how to create a singly linked list of given size. Okay, so before that we are going to discuss all the steps that are involved to get a single linked list. Okay, so the first step will be, we'll see that how to declare an isolated node. That means we'll first declare a isolated node. Isolated or independent node means it has not been added to any linked list, it is isolated. Okay, so after declaring a isolated node, we are going to consider two scenarios. First scenario will be that we'll consider that if linked list is empty. So if linked list is empty, then head should be null. Okay. The second scenario is that if linked list is non-empty. So in both these scenarios, we'll see that how we can add this isolated or independent node, okay, into the linked list. Okay, so let's start from scratch. So first we're going to see the code that how to declare a isolated node. Okay, so here is the code to get the isolated node or independent node. So to get the isolated node, what you need to do, you need to first define a temporary pointer, and that pointer is of course will be pointing to this structure. Hence the data type should be struct node start temp equals to null. That means temp is initially pointing to null, and after that I will allocate the memory for this structure dynamically using the struct node star malloc function, and size of will be struct node because this is a structure or a struct node data type. Hence the size of inside size of function will pass the struct node. Okay, so by this statement I hope you have understood that by this statement we will be able to get an memory or a space in the RAM, and that memory will be called as isolated node. Okay, so I hope this line, the temp equals to struct node star malloc, you have seen in the previous video in which we have introduced ourselves to the linked list. So okay, so if you have not seen the previous video, then please go back and see the video, and after seeing that video, I am damn sure that you are going to understand this video completely. Okay, so now let's move forward. After we have got the memory or space in the RAM for the isolated node, but what we need to do, we need to update the values of the data part and the next part. Okay, so as this is isolated, hence the next part should be pointing to null. That means it should not point to something, as it is isolated, so it should be pointing to null. Hence if we want our next to get value null, how we can do, we can do start temp dot next. Okay, do note here is that start temp dot next is similar as temp arrow next. Okay, so if you do start temp inside parenthesis dot next, what will happen is that you will get the value of the next inside this node updated as null. Okay, similarly if say the data value is 1, then if you do start temp data, then the data part will get value 1. Okay, so after this piece of code, what you got an isolated node with the value inside it 1, and it is pointing to nothing but it is pointing to null only. Okay, and one more thing, we have a temp here which is pointing to this node. Okay, and also we have a head, okay, which is pointing to null at the starting when linked list is empty. Okay, so now we are going to consider in the next scenario, and that scenario is that how to add the isolated node into an empty linked list. Okay, so make sure that if I say empty linked list, that means the head is pointing to null, as we know that the purpose of the head is to point to the first element of the linked list, but here the linked list is empty, hence the head should point to the null. Okay, so now let's go on to the next slide discussing this first scenario. Okay, so what we want to add that isolated node into the empty linked list to get this linked list. Okay, so how to do that? Okay, so as we have discussed this piece of code in the previous slide only, now let's move forward. So to do that, if the linked list is empty, then definitely head is going to be null. Okay, so hence I will do if and else statement, check if linked list is empty or check if head is equals to null or not. If head is equals to null, then do head equals to temp, as we know that temp has the value 100 because the address of this node is 100 here. Hence temp is pointing to this structure, which means that temp has the value 100, and if I assign the value of temp to the head, then automatically the value of head will become 100, and hence finally the head will point to the first node of the linked list. That means we will get our new linked list, which is now non-empty with one element inside our linked list. Okay, so as we know the definition of head, that head always points to the first node, hence here we got a linked list in which we have a one element or one node initially, and head is pointing to the first node. Now we are going to consider the next scenario in the next slide, which is that how to add an isolated node if we have non-empty linked list. Okay, that means we have some element already present in the linked list. Okay, so let's consider this scenario in this slide. So we have already discussed the if part in the previous slide. Now in this slide we'll see the else part. Else part specifies that linked list is non-empty. That means it has already some elements. So suppose we have a linked list, non-empty linked list somehow, okay, and in that linked list we have 3 elements. Okay, now we want the 4th element. This is an isolated node. Okay, we have declared the isolated node and we have discussed that how to declare an isolated node in the previous slides only. So this is the isolated node we have, in which temp is pointing to this node. Okay, now we want this isolated or independent node to get added in this linked list. Okay, so you can see we have 3 elements in this linked list with head pointing to the first node. So how we can do? So by writing in the else block, we need to first traverse through list, because to add this 4th node inside the linked list, what we need to change? We need to change the null value from we need to change this null value to 400. That means from null to 400. Okay, then only this link will be possible. Okay, so to make the link, we need to update this value as 400. So how to do? So we are going to traverse the linked list, because we cannot directly fetch this part. Okay, this is not an array. So this is one of the drawback of the linked list, that we cannot directly fetch any node. Okay, so to fetch any node, we have to we have to use a pointer or a temporary pointer, so that we can run through this linked list. Okay, so to run through this linked list, what we are going to do, we are going to define a pointer which will point to the structure struct node star p. So p is a pointer. Initially it is pointing to null, and after that in the next line I am saying that, oh look, I am going to start running through this list by using a temporary pointer p, which is now pointing to head after this. So head, if you will assign the value of head equals to p, that means the p initially was pointing to null, but after this statement p equals to head, now p will point to this. That means p has an address equals to 100. P has a value equals to 100, which means that p is pointing to the first node. Okay, now we want to traverse, we want to go up to here, up to this node. So how to go? We know that to use while loop. Okay, so inside while loop the condition will be check whether star p dot next is not equals to or not, and if it is correct, then do p equals to star p dot next. Okay, so let's go and understand this while loop. Okay, so first, after this line, the value of p has become what? P has become 100. That means it is pointing to this. Okay, if you check star p dot next, so star p dot next in this case will be 200. Okay, because p is pointing to this node, okay, first node. Hence if you do star p dot next, then it will then the value of star p dot next will be 200, and it is not equals to null. That means this condition is satisfied. Hence it will come inside the while loop, and after coming inside the while loop, what it will do, it will say that, oh look, I am going to point to the next node. So how to point to the next node? We will update the value of p as star p dot next. Okay, so we know that initially when it was pointing to the head or the first node, the address of the value of p was 100 and the value of star p dot next is 200. So if you do this line, then the value of p will become 200. That means that means the updated value of p will become 200, which means that now p will point to this node, because the address of this node is 200 and the p has stored the value of 200, which means p is now pointing to this node. Okay, and after that again while loop will run. Again it will check whether star p dot next is not equals to null or not. So in this case star p dot next is 300, which is not equal to null. Hence this condition is again satisfied, and after that again I will do, oh look, I'm going to update the value of p from p to star p dot next. So in this case star p dot next is 300, hence the value of p will get changed from 200 to 300. That means it will point to this node now. Okay, that we wanted earlier. So now finally we have reached at this point. Okay, now again while loop will run. It will check whether star p dot next is null or not. So in this case it is null. That means this condition is not satisfied. Hence it will come out of the loop. When it come out of the loop, then what we need to do, we need to change the value of null from null to 400. That means basically as p is now pointing to this, so if you do star p dot next equal to temp, then what will happen, star p dot next means this part. Okay, so this part will get value as 400 because temp is pointing to this. Okay, so hence finally we got our required linked list, understood the essence of single linked list. Now in the next video we are going to write the exact code in the Visual Studio IDE to actually create the linked list. In this video we have discussed that discuss the pseudo code only, that how we exactly make a linked list or a single linked list step by step. Okay, so this video has become long, so I will write the code in the next video in the Visual Studio IDE. So that's it for this video. I hope you have understood it completely. Okay, so that's it. Thank you and have a nice day, and Jai Hind.